Bonjour. I will switch in English because the next talk will be in English. So here is Mess. We will talk about automatic tools that he used in order to automate things for deployment and development. Please encourage him. And okay, guys. And Mess, it's your turn.
All right. Is the mic working? Yeah, perfect. All right. Thanks a lot for coming. I'm going to talk about automating developer environments. But before we get started, I want to make a little clarification. So when I say developer environments, what I mean is kind of the set of tools and services that you're using to build your product, and not your editor or your IDE. In this talk, I don't really care about what you use to manipulate the source code. I care about the programming language you're using, the database you're using, the cache, the message queue, all these kind of things. So this talk is going to be about how to get all of that set up on your computer so you can actually work on your project. But a bit about me first. I have a master's degree in computer science from the University of Copenhagen, and for the last 5 years or so, I've been working as a full stack engineer. So that means working on the backend systems like APIs and infrastructure and stuff like that, and then also working on the front-end systems. So that would be like, in my case, mainly websites written in React using Webpack as a build tool. But I've also done a bunch of continuous integration, so automated testing, deployment, monitoring of the services, and kind of these infrastructure things. So I've done a little bit of everything. And 9 months ago, roughly, I changed jobs to a small startup. And when you change jobs, at least in my experience, if you're lucky, you get a new laptop, like this shiny one I have here. But you certainly get a bunch of new code. So in this case, it's a small startup, but we have still 6 repositories with a ton of code in it. And I need to get all that code down on my machine and get that code compiling and running somehow on my machine. And normally, if you're lucky, there will be a README. So you clone a repository, you look at the README, it has some guides on how to actually install these things that you need. But if you're not lucky, which I wasn't, then you have to write the README. And how do you do that? You find a coworker who is able to compile the project or make it run. And then you ask your coworker, do you remember what you had to install in order to get to this state that you're in? And they're like, yeah, maybe let's see if we can do that together. So in my case, I wrote this README for just one of the projects, which is a backend written in PHP. So I'll quickly go through the steps just so we can see how tedious it really is. You have to install PHP, then you have to install 3 extensions to PHP. You have to install Composer, which is this package manager for PHP. Then you have to install Nginx, and then you have to install Redis, and you actually also need to install MySQL, but we forgot that in the README, which is another common thing that happens, like the README is incomplete or it drifted and it doesn't really tell you how to get to the correct state. But once you've installed all this software, and hopefully you get the right versions, right? Then you have to configure some, like in this case, your PHP has to get a bit more memory, and ECC hosts has to have a mapping. And then at the end, you can start all the services, and now you're ready to work on this project. So this is, in my mind, a very tedious and boring thing to be doing. But you might argue that it's okay. It's just, you have to do it once for a project and then never again. But in my case, I had to do this 6 times over 3 months, and then it becomes extremely boring. And this is just to get everything up and running. Right now, you finally have your PHP backend, in this case, running. Now you need to learn the workflows that comes into working on this project. So like, how do I get the database in a proper shape? How do I apply database migrations? Or how do I clean the Redis cache? And all of these kind of things that you have to do in order to work on the project, but it's not really related to the actual feature or bug that you're trying to fix. So while I was going through this, like once again, when I joined this new company, I had this feeling that we should be able to do much better than this. We've certainly done a lot better than this when it comes to like deploying and testing our code. We've optimized like every aspect of that. So you deploy, you just push to a master branch, and it's on the servers in a couple of minutes. This is definitely not the experience when you set up your local environment. So when I was going through all this, I kind of made like a wish list, like how would this look like if in the perfect world, what would a development environment look like? And the first thing that kind of comes to mind is that it should be trivial to run all this locally. I don't want to have to go through this README, install all this software. I just want to get the code and make it run somehow without thinking too much about it. And this is, again, in the ideal world, right? And then once the service is actually up and running, I wanted to react to the changes I make to the code or the configuration. I don't want to have to remember that, that's right, when I change this part of the code, I have to restart the server in order to see the change. Or if I add a new package, I have to shut down the server, install the package, and boot it up again. All of these things, I just want to focus on changing the configuration of source code and then see the effect, and not all the other stuff. And kind of lastly, as an umbrella catch-all, I just want to automate all of these small, boring things that we can reasonably automate. So getting a database with the right database user, with all the migrations applied, so all the tables that you need, stuff like that. I don't want to be typing like commands in my terminal in order to do this. I want to have it automated if possible. Otherwise, I want to run a single command to do this. And in general, what I want to be able to do is I want to be able to focus on the task, so fixing a bug or adding a feature, and not so much the mechanics of the tools that kind of make it possible. So sometimes it's fine to focus on the tools when you're trying to achieve something with the tool, but when what you're trying to do is just build out your product, I really don't want to be worrying about this. So we spent some time at my current company Family trying to figure out, okay, so looking at this wish list, how could we actually achieve this? And we tried a bunch of different kind of technologies. And what we came, in the end, I think after a couple of months of kind of just playing around with it after hours, we had a setup that seemed pretty cool. So I took that setup to a local meetup in Copenhagen, where I kind of did a lightning talk, so 8-10 minutes, and I showed what we had, and people thought it looked pretty cool. So they wanted us to open source it. But what we made was like very specific to the company. So what we did instead was we took all the ideas from automating this at Family, and then creating an open source version where you can see how these tools play together and how you might automate this kind of process. So that's what I'm going to show now. So it's this fake project where you have a backend written in Python using Flask. You have a frontend written in React using Webpack as a build tool, and you have a MySQL database, and you have a bunch of, well, you have one migration script that kind of creates a single table. So now I'll see if the demo guards are happy. Okay, so maybe make this a ton bigger. All right. So because I was afraid we didn't have any internet here, I did two things. So you kind of just have to trust me that that's all I did. I cloned the repository. It's called family plan. And then I ran a single command called make install. And that command installed a bunch of software on my machine. And it also installed this script called plan. So the idea is that plan, that's now the command that you use to interact with your whole developer environment. So if we kind of look at it, we can see there are some interesting commands. Up might be an interesting one. So this command has tab completions and help. Oops, that's the wrong one. So let's see what help up does. So it says it starts the current environment stack. So let's give that a go. So in this case, we've cloned the repository, ran a single command, and now we are running this one, which will boot up the front end, the back end. It will boot up MySQL. It will boot up a little service that runs your database migrations. Now they're all kind of trying to connect to each other. If you're quick, you can kind of see it applied a single migration with a checksum, and it started a backend in dev mode, and the Webpack frontend is now compiling. So now we can go to localhost 8080, and we get this very basic-looking website. There's a little introduction, and then crucially, it says no messages yet. So in order to create a message in this system, so this is just like showing how these things fit together. you would go into your project. You have one of your services is this migrations container. We add a file called hello WEB2DAY. And then we paste this in. All right, so this is just like writing a normal migration SQL file. But what the service did is that one of the services saw that we added a new file and it ran it with a checksum. So now if we refresh, we have a nice message. So normally in my experience, you would have to like run a script that applied migrations and stuff like this. In this case, it just picks it up. So let's try and add another one just to introduce a bug. All right. So it saw that the SQL file was changed and it's rerunning it. So now if we refresh, we only get one message. Oh no. But if we look in the database, we have, okay, I did this last night. We should see that we have, let's close this. Connect again. We see that we have this 3 messages, so it applied the migration twice, so we have three messages. But we're only showing one, so there's probably some bug in the backend. So let's have a look at this Flask application. And I'm going through this a bit quick, but it's because the source code really doesn't matter in this case. It's more the workflows and the stuff you don't need to do. So in this case, it's pulling out all the messages. It was just asking for 1, now we're asking for 20. We refresh the browser and you get it. So we didn't have to restart the Python server or anything like this, which is, of course, that's kind of normal, but in this case, we didn't even have to really start the service either. And then finally, just to show that you can do this with all different kind of things, we could go into the front end and kind of delete this introduction. And now it reloads. So in this case, we were able to kind of change the database through SQL migrations, change the backend, and change the front end. And the last thing you need to see is that we also have this db and then restore command. So this is a way of automating. So okay, the migration was applied 2 times while editing, which is not then you won't get the state that the database is in. So if we want to start from a completely new database and apply all the migrations, we have a single command that we can run that does that. So it kind of restarted MySQL, ran the migration. So now we should see just 2 messages. All right, so this is a general idea. You have this kind of one single command to help you interact with your developer environment, and all the different services know how to recompile and kind of react to changes in the right way. So back to the talk. All right. So just what you saw is a single command line interface for your entire stack that has tab completions to help you explore things and help to kind of understand what things are doing. And we only had to run a single command in order to boot up all of these services. And there were no manual steps. Of course, there were 2 in the beginning, clone a repository, run a single command, but I think compared to going through this huge README, that's pretty good. So what I showed here, you can find that on github.com, family/plan, where you have all the source code and the components in order to see how this works. So now to the interesting bit, which is how did we actually achieve this? And we did that using 3 different technologies, where the first one is Docker, represented by the emoji whale, and the next one is Make, represented by the robot, and Bash, represented by the laptop. So for the remainder of this talk, I'm going to go through how we use each of these tools and how they kind of play together in order to get this automated setup. So first is Docker. So how many has used Docker before? Ah, that's awesome. All right. Because I have a very brief introduction, but it's very lagging in detail. So just bear with me, this is going to be quick. There are a couple of concepts you need to know. You have one is a Docker image, and you can think of that as a lightweight virtual machine image that you use to run Linux binaries. And that's like leaving out a ton of the details, and it's mostly wrong. But like intuitively, if you think about it like that, then that's enough to understand the rest of the talk. Then you have a Docker file, which is simply just a text file with a set of commands that you use to build a Docker image. And then you have a Docker engine, which is the thing that runs your image. So You have one for Mac called Docker for Mac, for Windows called Docker for Windows, and you have Docker, which is just for Linux, and you have some nice tools if you want to run it in an actual virtual machine as well. So that's kind of how it fits together. A Docker file describes an image. You can take an image and run it anywhere where you have a Docker engine. So a very, very brief example is this. This where at the top we have a Docker file. It says from Ubuntu 17.04, which means we are extending another image that contains all of the Ubuntu binaries that ship with the Ubuntu distribution. Then we run apt-get update to update the cache, apt-get install to install Node, and then we say the command is Node. So what this means is that it builds an image that has all the binaries from Ubuntu and also Node, and then when you run the image, all it does is run Node.js, so it will start a Node REPL. And then in the middle we have docker build-t WEB2DAY-node, which just means build a Docker image and call it WEB2DAY-node and build it in the context of the current directory. And then this will take a while. It builds an image. And once you have this image, you can run it, saying docker run-it WEB2DAY-node, which means run the starter container based on the image called WEB2DAY-node and run it as an interactive session with a TTY terminal attached. So if this wasn't just a screenshot, I could type in things and have a fully functional Node environment. And the nice thing about this is that the first two parts, writing the Docker file and building an image based on it, could have been done by anyone, and it could have been compiled anywhere. So if you want to run Node, there's already an image for that, and you can build the image. If you have your own set of tools you need, you can build it locally, or you can build it on your CI system, and then ship it to a registry of images somewhere. But back to how we kind of use Docker in this context. So in order to automate these things, so we had 3 different services we want to run. We have a migration service, a front end, and a back end. So in order to kind of fit into this framework of automating things, they have to provide 3 things. So the first one is a Docker file. And this Docker file should describe the kind of runtimes you need and the tools you need in order to build that product. So for a front end, it might look something like this. It says we're extending the Alpine version, well, the Node 7.04 on the Alpine Linux distribution. Then we are installing Bash, and we are installing Yarn. And then we are copying in a script and setting that script to the command. So this is a very small Docker image, and it only has a few set of tools. It has Node, NPM, Yarn, and Bash, and nothing else. And then we copy in this little shell script, which gets me to the next part, which is, so you have the Docker file with all the tools. And then you have this watch script that's supposed to handle the kind of life cycle of your service. So this looks something like this. If you just ignore the top part at the beginning, you go into a specific directory, you trap some Unix signals, which is not super important. Well, it is important, but you can come ask me afterwards if you want to know why we do that. And then we go into an infinite while loop, where we just say, okay, as long as this container is alive, I want to be installing dependencies. So for a front end, that's usually npm or yarn install. Once it's done with that, it will start Webpack in the background, and then it waits for file changes. So if you boot up the container, it will now have all the npm packages you need. It will have started Webpack in the background, so Webpack is compiling your assets and starting a development server. And now it's just blocking using iNotify, so it's not like a busy loop, but it's just blocking on file changes. And these file changes are package.json, yarn.log, and webpack.config. So if any of these 3 files change, it will kill the Webpack server, reinstall npm dependencies, and start again. So this is, at this point, you get something that you usually wouldn't have in a system that's running on your host machine, because this can actually react to changes of your npm dependencies as well, and then restart the server for you. So this is a bit more versatile, and it does a bit more than you would usually do. And all of this is running inside of a container. It has nothing to do with your host. And the last thing you need in order to comply to this interface, if you want to run your service in this framework, you have a Docker compose file, which basically just have to describe, okay, if I want to run this service locally, what do I need? I need to set some environment variables, I need to expose some ports, and I need, crucially, to mount in some source files. So if you used Docker before, you might think that the image I showed you is a bit weird because it has no source files in it, so it can't really build your product. But the reason we didn't do this is that we mounted in at runtime instead. And the nice thing about this is that now I never have to rebuild that Docker image. So I build that Docker image once, and it has the tools, and then if I change a Git branch or I pull down some changes, the container will just get the new source code and react to the changes. Yeah, so a very quick recap of the Docker part of this, which is provide a Docker image. The image should only have the tools that you need, not the source code. Write this little bash script that takes care of booting everything up for the container to build and then reacting to code changes. And then lastly, you need to write a compose file that tells you what kind of source files you need to mount and what kind of ports you need to expose. The very nice thing about this is that now we have completely reduced the host dependencies. So I don't need Node, I don't need Yarn, I don't need PHP, I don't need to install any of this on my own machine. I can just pull down a Docker image with this installed and run it with this compose file, and then it will kind of be a self-contained system with all the tools it needs. So you can kind of go through all your READMEs, delete that whole part of it. And a very nice thing if you're working on in a company where you have more than one team. So let's imagine that we have two teams. They have their own backends. One is in Python, the other is in PHP. And now the Python people, they want to switch from Python 2.7 to Python 3 something. And normally, in the normal way, they could choose to do that. Of course, they could update the README, and then everybody who wants to run it locally, they would have to go. Oh, by the way, now you need to install Python 3 on your host system as well, and make sure it doesn't clash with Python 2. But in this case, where they are what they're shipping is a Docker image with the tools, they can just change the tools, use Python 3 instead, build a new image, push it. And nobody will actually know that this changed. So all of the other developers can just be happy working on their own products. And I think this is super powerful because it gives you ownership of your whole tooling around building your product without having to bother your coworkers about it. And the nice thing from an automation perspective is that now we have this very uniform way of dealing with services. So if someone says, all right, I want to write the new front end using Cycle.js, and I want to use Yarn instead of NPM, and all these kind of new things, then they can go do that. They just have to follow these 3 steps, and then it just works. And it's very easy to script, because now we have all these services running as containers. We can do whatever we want with them. So that was the Docker aspect of it, and I think that's the most crucial aspect, because that's what actually reduces your host dependencies. The other part is make. How many people have used make? All right, you can use another tool if you don't like it. I happen to like make. It's from the 70s, and it's good at automating things that tasks where they kind of depend on each other. It's archaic, it's a pain to debug, and it's generally pretty annoying. But I love make, and I'm not sure why. I get a warm, fuzzy feeling whenever I write a make file. So that's what we chose to use. And it is, I think, very good at automating things where you have a very clear dependency graph between your tasks. I think make is pretty concise at describing those kind of relationships. So what we use make for in this case is install some tools. So in this case, it will install Docker. It will install a few other things that you still need to have on the host system. It will clone a bunch of repositories. So it won't do that in the family dev example, but at family it will clone 8 other repositories, because we have a project separated over many repositories. And then it kind of looks at these 8 repositories, sees if they have a folder called Docker with a Docker file in it. If it does, it will build those images, so you have these development images on your machine. And if anything changes, if the Docker file changes, it catches that and rebuilds the Docker file. The Docker image. And what we really use make for is kind of automating the few things that still need to happen on your host system. So you still need to install Docker, for example, and you need to build these images on the host. You could pick any tool for this that will automate tasks. We just happen to choose Make because I've written a bunch of Make files over the years, and I really like it. All right, so the last aspect is Bash. Again, you could use something else, but the crucial aspect is that you want to provide a CLI, so a command line interface, for your whole developer environment. This will help you make it more discoverable for your coworkers, what you can do with it, and you can add tab completions and all this kind of stuff, so you don't have to go looking through a README to see, like, how do I delete the database and create a new one based on the migrations and stuff like that. So yeah, Bash is used to create this interface for your developer workflows. And we chose Bash because we wanted to kind of optimize for extensibility. So in our case, most of the developers at Family, they are pretty comfortable writing small Bash scripts. So for us, we made it very easy if we want to say we want to be able to write plan foobar. So we are extending plan with a command called foobar. Then we would have to write a foobar.sh script, put it in a folder, and that script should reply to the input. So if you give it help, it should print a help message. If you give it completions, it should give a list of possible completions. And if you give it anything else, it should do whatever you intended the script to be doing. So a small example is this one, which is, so you can see it kind of fits into one page, so it's not so big. The important part is at the bottom where it kind of switches on the input, and it says if it's completions, write the list of Docker containers that it knows about. If it's help, write a little help message. If it's a Docker container that exists, then kick it. And what do we mean by kicking the container? You go into the container and send the SIG-hop signal to the process number 1. So the reason we need this is that imagine that your Python service is running. It's all of a sudden it broke. It just stopped reloading code changes. I mean, that happens. Software breaks. In that case, you could decide to restart the container, but that might take a couple of seconds to do. Like, it has to boot down and boot up again, and it might then need to reinstall pip dependencies and stuff like that. So we would rather not restart it. So instead, we can go and we can give it a kick, and it will kind of try and recover. So I'm just showing this as an example of a workflow that we're sharing, and this is kind of the amount of code you would need to write. So a little bit details on how it works. It's very, very simple. We have a dev.sh script, which is that's the command line interface, and it's basically just it's just a proxy. So if you call dev and you give it the input build, it just goes into the command folder, looks for a script called build. If it's there, it executes it and passes on the rest of the arguments. So this script is tiny, doesn't really do anything. And the dev.completions is to provide ZSH completions. So if you use the ZSH terminal, then you're kind of used to getting tab completions. And this script does that. And again, this script doesn't really do anything. It goes down to the command they're trying to run, and it asks that command to provide the completions. So these are just small proxy scripts that redirect the commands to the right script. All right, so that's kind of how we did it, and you can kind of find the code online and play around with it. And now it's like, is it worth it? And I found this very nice XKCD comic that if you like automating things, this is a horrible comic, because it says how long you can work on making a routine task more efficient before you spend more time than you save, which sounds okay, but then it says across 5 years, and that's the horrible part. So if you do something 50 times a day and you can automate it, and by automating it you save 1 second, then you're allowed to spend 1 day optimizing, automating this task. And in my experience, nothing takes less than a day to automate. Especially enough if you actually want it to work. So if I do this for 1 day, then in 5 years, I've saved a second. So this is a very annoying slide if you like working on these kind of things. But I bring it up because for one thing, you are not automating things for yourself, you're automating things for all of your coworkers. So the more coworkers you have, the more time you might potentially save. But to me, saving time is not the crucial aspect of this. The crucial aspect of automating all these tedious things is to remove this cognitive overhead of stuff you have to remember when you're just trying to build your product. So So all of these small commands, optimizing stuff like reinstalling npm dependencies and stuff like that, that's just to make sure that I don't have to think about that when I'm actually building a feature. I can focus on changing the code in a way that fixes a bug or stuff like that. So I can kind of relax a bit. I don't have to remember these 100 commands. I can just look at the code and fix that instead. And it should hopefully give you a much faster onboarding process. So if you have a setup like this, then in theory, what would happen is you get a new developer, you give them a computer, you tell them to clone one repository, run a single command, go get a cup of tea or cup of coffee, while it kind of installs and compiles everything. And now you can run plan up, and now you have the whole thing running. So this means that within 10 minutes, you will be able to work on all the projects in the company, or at least the ones that are relevant to you. And I think this is a very, I mean, I would love to join a company where this is the onboarding process and not 6 months of writing READMEs. So I think that's a pretty cool takeaway as well. And what's really interesting that I hadn't thought that much about at the beginning is that this allows us to share these workflows really easily. So I had a feature I was working on where I constantly needed to get the database in a very specific state. And once I tested the feature, it would affect the database, so I had to restore to the previous state. So I wrote this little command called db, which can take a dump of your MySQL database or it can restore it. And the nice thing about this is it helped me, of course, with my little task, and I thought it was fun. But now, when I work on a feature and I find a bug somewhere in the system, but I don't have time to fix that right now, I can just say plan db dump. It creates a MySQL dump, puts it on my host system somewhere, and then I can open an issue and upload the dump. And I can say, hey, I found this weird bug. Restore this database, and you have a reproducible example. So this means it's very easy for us to share kind of these weird states that our systems might get in. And that's it. Thank you.